ஓம் ஸ்ரீ மகாபெரிவா சரணம். இன்றைக்கி நம்ம கிளாஸ் 9ஓட NCERT எக்ஸாம்பிளர் புக் இருக்கு இல்லையா, அதுலேருந்து கொஞ்சம் கொஸ்டின்ஸ் பார்க்கலாம். இந்த எக்ஸாம்பிளர் புக் அந்த கொஸ்டின்ஸ் ஹையர் டிஃபிகல்ட்டி லெவல் கொஸ்டின்ஸாக இருக்கும். பட் அது கான்செப்ட் அது தரோலி நம்ம அண்டர்ஸ்டாண்ட் பண்ணலாம், புரிஞ்சுக்கலாம். அது ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நமக்கு. இன்றைக்கி நம்ம பார்க்குற சாப்டர் சர்ஃபேஸ் ஏரியா அண்ட் வால்யூம்ஸ். ஸோ அதில் ஃபஸ்ட்டு நம்ம மல்டிபிள் சாய்ஸ் கொஸ்டின்ஸ்க்கு போகலாம். அப்புறம் ஷார்ட் ஆன்சர் கொஸ்டின்ஸ், அப்புறம் லாங் ஆன்சர் கொஸ்டின்ஸ், அப்படி போகலாம். ஸோ ஃபர்ஸ்ட் மல்டிபிள் சாய்ஸ் கொஸ்டின்ஸ். ஃபர்ஸ்ட் கொஸ்டின். In a cylinder, if the radius is halved and height is doubled, the volume will be, you have 4 choices. A, same, B, doubled, C, halved, D, 4 times. So, இதோட சொல்யூஷன் எப்படின்னாக்க, நமக்கு தெரியும் இல்லையா, வால்யூம் ஆஃப் அ சிலிண்டர் V is equal to pi r square h, where r is the radius, h is the height. So, இப்போ கொஸ்டினில் என்ன கொடுத்துருக்கான்னா, the radius is halved. So, it will be r upon 2 square. இங்கே height is doubled. So, instead of h, it will be 2h. Okay, so this will be the new volume. So, it will be pi r square upon 4 into 2h. Right? So, that இது 2 and 4 will get cancelled. So, you will get pi r square h upon 2. Correct? So, this was the original volume. And now, இங்கே இது என்ன இருக்கு? By 2 இருக்கு. So, it has become half. So, the correct answer is C, halved. So, the correct option is C, halved. Okay, let's go to the next one. Next question. The radius of a sphere is 2r. Then its volume will be, first option A, 4 by 3 pi r cube. Second option B, 4 pi r cube. C, 8 pi r cube by 3. And D, 32 by 3 pi r cube. So, either how will you work out? We know volume of a sphere V is 4 by 3 pi r cube. Now, the radius of a sphere is 2r naka. This will be 4 upon 3 pi. Instead of r, you will have 2r whole cube. So, that will be 4 upon 3 pi 8r cube. That will be equal to, in the 32 mala pi r cube upon 3. So, D is the correct option. Next one. The total surface area of a cube is 96 centimeter square. The volume of the cube is, you have 4 options. The first one, 8 centimeter cube. Next, 512 centimeter cube. Third, 64 centimeter cube. Last, 27 centimeter cube. So, how will we work it out? Now, we know total surface area, TSA of a cube, evlo 6a square, where a is the side length. Correct? So, inga they have given it as 96 centimeter square. So, if you solve this, 6a square is equal to 96 na, a will be equal to how? A square will be equal to 96 upon 6, which is equal to 16. So, a will be equal to 4. You take only a square 16 na, square root of 16 is plus minus 4. But length anathanala, it should be positive quantity. So, a is equal to 4 centimeters. So, a is equal to 4 centimeters na, volume is equal to a cube. Volume will be equal to a cube. So, volume will be equal to 4 cube centimeter cube. Okay, which is equal to 64 centimeter cube. So, C, option C is the correct one. Next, a cone is 8.4 centimeter high and the radius of its base is 2.1 centimeters. It is melted and recast into a sphere. The radius of the sphere is 4 options. 4.2 centimeter, 2.1 centimeters, 2.4 centimeters, 1.6 centimeters. இல்லை நம்ம யோசிக்கணும் இப்போ the cone is melted and recast into a sphere. That means the volume of the cone will be equal to the volume of the new sphere. Correct? So, if you equate this volume of the cone to volume of the sphere, then we'll be able to solve the problem. So, first volume of the cone கண்டுபிடிக்கலாம். 1 by 3 pi r square h. So, if you substitute the values, so 2.1 square 4.41 வருது. இங்க height 8.4 வருது. So, இந்த pi will remain as pi. 3யும் இதுவும் cancel பண்ணா 3 into 2.8 will be 8.4. So, we get this value. Okay, keep it as it is. Now let's go to the volume of the sphere. Now let R be the radius of the new sphere. So the volume will be 4 by 3 pi r cube for the sphere. That we have to equate to the volume of the cone which was there earlier. So if you equate these two, then r cube will be equal to this. 4 by 3 you take it to the other side, it becomes 3 by 4. Pi inga kondu ponaka denominator la varum. So pi get cancelled. So you will get r cube as this value. Now if you solve, what will you get? In the 4, in the 2.8, 0.7 varum, and this 3 into 0.7 will give you 2.1. So it will be 2.1 into 4.41. And what is this 4.41? That was 2.1 square, correct? So this is nothing but 2.1 the whole cube. So if r cube is 2.1 cube, then r will be equal to 2.1 centimeters. So that is the answer. So option B, 2.1 centimeter is the correct option. Sometimes it's better to keep the calculations for the last step. For instance, in this case, for the volume of the cone and the sphere, when we equate it, we need not calculate like 2.1 divided by 3 or 8.4 divided by 3 at the first step, because automatically this pi and pi will get cancelled, 3 and 3 will get cancelled, and the last step, when we divide 8.4 upon 4, we get 2.1 automatically. So when r cube is 2.1 cube, we get r as 2.1. This way it's always better to keep the calculations for the last step, so that cancellation of the common values will be easier. Next question. In a cylinder, the radius is doubled and the height is halved. Then the curved surface area will be halved or doubled or same or 4 times. So how will we do this? Now curved surface area CSA of a cylinder is 2 pi RH, right? Now the radius is doubled. So let's say it's 2r. And the height is halved, so it will be h upon 2, right? So 2 get cancelled, so 2 pi rh. In other words, this 2 pi rh is the same. So the correct option is C, option C, that is same. The curved surface area will be the same. Next question. The total surface area of a cone whose radius is r by 2 and slant height 2l is, they have given 4 options. A, 2 pi r into L plus r. B, pi r into L plus r upon 4. C, pi r into L plus r. D, 2 pi rl. You know, total surface area of a cone is equal to pi r into L plus r, right? Now, radius is r upon 2, so here it will be r upon 2. Slant height is 2l, okay? The radius is r upon 2 as discussed earlier. So what will we get over here? So pi r, let it be as it is. Upon 2, if you take inside the bracket, 2 by 2 cancelled, just l will remain, and this will become r upon 4, right? So that's the answer. Pi r l plus r upon 4. So the correct option is B, pi r within brackets L plus r upon 4. Next question. The radii of 2 cylinders are in the ratio of 2:3 and their heights are in the ratio of 5:3. The ratio of their volumes is, there are 4 options. A, 10:17, B, 20:27, C, 17:27, D, 20:37. Let's work this out. So say the radii of the 2 cylinders are R1 and R2 and their heights are H1 and H2 respectively. Now what we have been given is R1 upon R2 is equal to 2 by 3 and H1 upon H2 is equal to 5 by 3. Okay. Now ratio of their volumes will be equal to pi R1 square into H1 divided by pi R2 square into H2, right? Now pi gets cancelled and this is nothing but R1 upon R2 the whole square into h1 upon h2. And that we already know as 2 by 3 the whole square into 5 upon 3. Correct? So that is equal to 4 upon 9 into 5 upon 3, which is equal to 20 upon 27. So this is the answer. So the correct option is option B, 20:27. The next question. The lateral surface area of a cube is 256 meters square. The volume of the cube is, first option 512 meter cube, second option 64 meter cube, third option 216 meter cube, fourth option 256 meter cube. So how will we do that? So the lateral surface area of a cube, LSA, is 4a square. That's the formula where a is the side length. Now that is given to be 256. So if you solve it, a square will be equal to 256 upon 4, which is equal to 64. So a will be equal to 8 meters. We have only positive value as this is the side length. So if a is 8 meters, the volume which is equal to a cube will be equal to 8 cube. 8 cube is equal to 512 meter cube. So 512 meter cube is the correct option. Option A. Option A is the correct answer. Next question. The number of planks of dimension 4 meter into 50 centimeter into 20 centimeter that can be stored in a pit which is 16 meter long, 12 meter wide and 4 meters deep is, they have given 4 options, 1900 or 1920 or 1800 or 1840. So how will we do this? Now first we'll find out the volume of each plank and then find the volume of the pit so that we'll know how many planks can be stored in the pit. Okay. Volume of a plank is equal to length into breadth into height, right? So according to the given dimensions, now we have converted centimeters to meters, so we get 4 into 0.5 into 0.2 meter cube, that is equal to 0.4 meter cube. This is the volume of a plank. Now let's find the volume of the pit. Now the volume of the pit will be 16 into 12 into 4 meter cube, correct? So the number of planks that can be stored inside the pit is equal to volume of the pit divided by volume of the plank, correct? So now that will be 16 into 12 into 4 upon 0.4. This will be equal to 10. So 16 into 12 into 10, that gives you 1920. So the correct option is B, 1920 planks can be stored inside the pit. Next question. The length of the longest pole that can be put in a room of dimensions 10 meter into 10 meter into 5 meter is either 15 meter or 16 meter or 10 meter or 12 meter. Now how will we do this? Now the length of the longest pole will be the diagonal of the cuboid. In this case that's the room. Say we are in a room. So it will be, say, from the bottom left corner of one side to the top right corner of the other side. So that's the diagonal. You know what's the formula for the diagonal of the cuboid? That is square root of L square plus B square plus H square, right? Where L is the length, B is the breadth and H is the height of the room. So according to the given question, we have right, square root of 10 square plus 10 square plus 5 square. How much is this? 100 plus 100, 200, 200 plus 25, 225. And what is square root of 225? 15. So the correct answer is the length of the longest pole that can be put in that room is option A, 15 meters. So option A, 15 meters is the correct answer. Next question. The radius of a hemispherical balloon increases from 6 cm to 12 cm as air is being pumped into it. The ratio of the surface areas of the balloon in the two cases is option A 1:4, option B 1:3, option C 2:3, option D 2:1. So how do we work it out? So the first radius, let it be R1, that is 6 centimeters. The second radius, when it increases, that is 12 centimeters. So we know that the ratio of the surface areas of the balloons in the two cases is 3 pi R1 square upon 3 pi R2 square, which is equal to, so this 3 pi will get cancelled. It is nothing but R1 by R2 the whole square, correct? Which is equal to 6 upon 12 the whole square, which is 1 upon 2 the whole square, which is equal to 1 upon 4. So the correct answer is option A 1:4. Now let's go to short answer questions with reasoning. Okay, write true or false and justify your answer. Next question. A right circular cylinder just encloses a sphere of radius r as shown here. The surface area of the sphere is equal to the curved surface area of the cylinder. True or false? See, this is the right circular cylinder. It just encloses a sphere of radius r. Okay, so radius r. Here this is also radius r. Okay, so this is the sphere. Now we have to find out if the statement is true. What's the statement? The surface area of the sphere is equal to the curved surface area of the cylinder. Now, here the radius of the sphere, this radius of the sphere, this is also equal to the radius of the cylinder, correct? Also, this diameter, that's the double the radius. The diameter, that is double the radius of the sphere, that is equal to the height of the cylinder, correct? So the radius of the sphere will be equal to radius of the cylinder, which is equal to r. The diameter of the sphere will be equal to the height of the cylinder, which is equal to 2r. Now surface area of the sphere is 4 pi r square, and the curved surface area of the cylinder is 2 pi rh, which is 2 pi r into h is 2r. So 4 pi r square, which means the surface area of the sphere will be equal to the curved surface area of the cylinder. That means the statement is true. Next question. An edge of a cube measures r centimeters. If the largest possible right circular cone is cut out of this cube, then the volume of the cone in centimeter cube is 1/6 pi r cube. Now we have to find out if this statement is true or false. Let's see. Now we have the cube and the largest possible right circular cone is cut out of this cube. Now we can see that if this side length is r, side of this cube is r, then the diameter of this cone is also r, correct? The diameter of the cone is r. Again, if the height of the cube is r, then the height of this cone is also r, correct? So the height of cone is r and the diameter of the base is r. Let's find out the volume of the cone. Now, you know the volume of the cone, the formula is 1/3 pi r square h. Here, the radius of the cone happens to be half of the side length of the cube, which is r/2. And the height of the cone happens to be r. So if you substitute those values, you get 1/3 pi r cube upon 4, which is 1/12 pi r cube. The given statement was the volume of the cone is 1/6 pi r cube, but we have got 1/12 pi r cube. So the given statement is false. Okay. We'll discuss more such questions in our next class. Till then, Om Shri Mahaperivar Sharanam.